8.2 is linear equations in two variables. An example of an equation in two variables is 2x minus y equals 5. A solution of an equation in x and y is an ordered pair that would be written x comma y. That produces a true statement when the values of x and y are substituted into the equation. So for example 1, they're going to give us the equation 2x minus y equals 5. And we're going to see if the two ordered pairs they give us are solutions or not. I chose to do this with writing with my finger so you could see each step. So I'm going to go ahead, I'm going to rewrite the equation 2, but I'm going to substitute in my x, which is 1, minus y, which is a negative 3. Sorry, that's not very pretty parentheses there. And I want to see, is this equal to 5? I'm testing it. So you could put a question mark there. So 2 times 1 is 2, and 2 minus a negative 5. I'll even change colors here. Add the opposite. Not a very good color choice there. But 2 plus 3, it now becomes, is going to be equal to 5. So the coordinate points 1, negative 3 are solutions to that two-variable equation. All right, let's try the next one. 2, substitute in my x, which is the first coordinate point, 2 times 4. Again, subtract our y, which is just 7. And does that equal 5? All right, let's multiply it out. 8 minus 7, because negative times the 7 is minus 7. Does that equal 5? That does not equal 5. Ooh, so I can mark that as it is not equal. So this is not an ordered pair solution to my equation that has two variables. Simple as just substituting those in. Now example 2 says finding solutions, and we're going to have a word problem. It's going to be about volcanoes. And the Hawaiian volcano, Mauna Loa, has erupted many times. In 1859, lava from the volcano traveled 32 miles to the Pacific Ocean at an average speed of 4 miles per hour. Using an equation in two variables, we can describe the flow of the lava toward the ocean. So first of all, I'm going to make my equation. My equation is right here in the center. And my equation is going to be that D is equal to 32 minus 4t. Sorry, I already did some substitution in here. So let me write that equation here real quick for you. D is equal to 32 minus 4t. T. Okay, that is our equation. I'm going to use that equation over here, and I'm going to substitute in each one of my values in the table. So I'm going to let t equal 0, t equal 1, and t equals 2. So I rewrote that with that substitution in. And so 32 minus 4 times 0, so 32 minus 0 still gives me 32. All right. 32 minus 4 times 1, because my t is 1, gives me 28. And 32 minus 4 times 2, 32 minus 8, gives me my solution of 24. Now, each one of those solutions then can be written as ordered pairs. It could be 0, 32, 1, 28, and 2, 24. Now, as I'm looking at that, I also want to solve, because our question was, we're going to describe the flow of lava toward the ocean. So we want to find the value of t when d equals 0. To do that, I'm going to go ahead and I'm going to substitute 0 in for my d, and that's going to equal 32 minus 4t. Again, that was my equation for my problem. Now, I want to solve for t, so the first thing I'm going to do is get t by itself. So to do that, balanced equation, again, I wanted you to see it in action. I'm going to take 32 off of both sides, leaving me with negative 32 equals negative 4t. I want to go ahead and find just solving for the single t. So divide both sides by a 4t, and by a negative 4, and I get the answer of t equals 8. So now I have solved that. It took about 8 hours to reach the ocean. Okay. They told me how far it traveled. They told me how fast, and I had to solve for how much time that took. The next part is going to be graphing a linear equation. This lesson is a little bit longer, has more examples, so I will probably have to pause after this one. So, graphs. The graph of an equation in two variables is the set of points in a coordinate plane, or a grid, that represents all the solutions of the equation. An equation whose graph is a line is called a linear equation. So here we have our graph. Is what they want us to graph is y equals 2x minus 1. So to do that, I'm going to solve. Now y is all by itself, so I'm going to use x as my input. I'm going to do the input in the equation and see what comes out as the output, and y is the answer. So when I put negative 2 in, my x in, 2 times negative 2 is negative 4, minus 1, or combining it with a negative 1, gives me negative 5. 2 times negative 1, my next input, is negative 2, minus 1 is negative 3, and so on and so on. When I do 0, it cancels this out, so that one would be 0, negative 1. I typed that wrong. This is a negative 1. Better change that over here then as well. And then if I put 1 in, 2 minus 1 is 1. If I put 2 in, 4 minus 1 is 3. Now I'm going to take my input-output chart and I'm going to change it into ordered pairs just by simply writing the x and then the y. Negative 2, negative 5, negative 1, negative 3, 0, change that one to negative 1, and so on. Now if we go ahead and after we have done our input-output, we've changed them into ordered pairs, we can go ahead and graph this. Now I'm going to change that one correction that I missed there. That's going to be a negative 1. So just a review on our graphing. My first point is negative 2, negative 5, or you can see it on the input-output chart. 0, 0 is the center of my coordinate grid, so I'm going to go ahead and I'm going to start at 0, 0. Negative 2 on the x-axis means I'm going to travel to the left 2 points. Remember, you read left to right first and then up and down on the page. So I traveled negative 2, so I went to the left. And negative 5 means I'm going to travel down. 1, 2, 3, 4, 5. There's my first coordinate point, negative 2, negative 5. Same thing for my negative 1, negative 3. Over negative 1, down negative 3. 0, negative 1. That means I'm not going to travel anywhere on my x-axis, but I am going to travel my y down 1. 1, 1 means my first positive x. I start at 0, I'm going to move to the right 1, and I'm going to move up 1. Both of those were positive. And 2, 3, over 2, and up 3. Now when I go to graph that, I can see if I can use a line to go through each of those coordinate points, because we said we were graphing a linear equation. If it is in fact a linear equation, when we connect the coordinate points, we will create a line. All right, let's pause for our next